An Introduction to the Windows of Laser and Optical Simulation Software LASCAD. Part 2. By Amin Hosseini. Laser Engineer and LASCAD Sales Manager. Multiple LASCAD windows in one frame. Tab boundaries is used to define cooling of crystal. You can define cooling as either by solid or fluid contact. For the fluid contact, additionally check the box Fluid Cooling. In case of solid cooling, the surface is kept at constant temperature, which is defined by the value in the box temperature, K. For fluid cooling, the latter value defines the bulk temperature of the fluid. In Material Parameters tab, you should enter your crystal data from data sheet of that company which you bought the crystal from. In the lower part of the window, more sophisticated issues can be defined, like temperature-dependent material parameters, or solids composed of two different materials. To take into account two different materials, the option button Two Materials A and B, where material B can be a heat sink material, has to be checked. Also in this case, parameters of material A, and on request B, can be made temperature dependent by inclusion of user-defined equations. Whenever you want to define your crystal doped and undoped portions, some changes should be done here. The appearance of this window depends on options selected in the tab Material Parameters. If one of the two options buttons with caption 1 Material is checked, only doped and undoped regions of the crystal can be defined by the use of the boxes below the label Pumped Region Extends. This configuration concerns a slab with the absorbed pump power density being computed numerically. The distribution of the absorbed pump power density can be computed by the use of the program TracePro and Zmax. Data generated with either of these two programs can be used as input for LASCAD, which interpolates the 3D data set with respect to the grid used with the FEA code. Entries for the tab Doping and Materials have no meaning with this configuration. If Integrate Input Data over Crystal Volume, and Show Result in the box for Totally Absorbed Pump Power is checked, the input data are integrated over the crystal volume, but are not normalized. The result of integration is shown in the box Totally Absorbed Pump Power, W, when FEA is completed. If normalize input data, and multiply them with Totally Absorbed Pump Power as entered above is checked, the input data are normalized, and then are multiplied with the value entered in the box Totally Absorbed Pump Power, W. FEA code has three parts. The first one is for analyzing different models and pumping configurations, boundaries conditions, material parameters, doping and materials, and some FEA running adjustments, which you watch the explanations. The second and third ones are related to results of FEA code.